So we're beginning our study of chemical reaction types. The first two that we are going to focus on are synthesis and decomposition reactions. The first is synthesis. Now synthesize, or to do any kind of synthesis, it means you're going to put things together and get something new and different than the original things. So the example that we're using, and we often see in textbooks, is this. So we have reactant A and reactant B, and they are two completely different substances, and they react to yield AB. So you see how they have combined, synthesized to form something new. Now remember the law of the conservation of matter, that matter cannot be created or destroyed. So that's really important when we're talking about chemical reactions, because you can't end up with something in your product that was not in your reactants. Okay, and even when you get into high school chemistry and you start balancing chemical equations, that will become even more important. That concept of the law of conservation of matter will be even more important then. Okay, the example chemical reaction that I'm going to show you, the reactants are iron, Fe. Okay, Fe is the chemical symbol for iron, and the other reactant is oxygen, O2, so this would be oxygen gas. And what happens is these go through a chemical reaction, a synthesis chemical reaction, to form iron oxide. That's what this is iron oxide. Now that's just a fancy name for rust. So this is the chemical formula, if you will, for rust. So if you have a bicycle that's not made of stainless steel and it has some exposed iron in it, it's going to react with the oxygen and the air around it, and it will synthesize to form rust. This is a synthesis reaction. And that happens especially in moist environments and in warmer environments. The drier it is, the less likely that's going to happen. Okay? So for the lab, when you get to practice doing a synthesis reaction, it won't be iron, you won't be creating iron oxide. You won't be having that chemical reaction. But I'm going to walk you through the procedure, and it's very important that you follow the procedure, and especially the safety precautions, because you are working with chemicals, and you'll be working with flame on some of these labs. So please take the time to read through the procedure carefully, know what materials you're going to be using, and know what safety precautions to follow. The materials for this lab will be test tubes. So you guys know what test tubes are, right? Okay. And there will be some distilled water that we will provide for you. So rather than tap water, you're going to use distilled water. And then phenolphthalein. It'll be in a liquid form. It'll be a solution. It's called phenolphthalein. I know it's spelled really weird. It's really long. It's got all these letters in it, and you're thinking, what in the world? But it's just phenolphthalein. Okay? And then you will also be using calcium oxide. All right. In the procedure, you're going to first of all put some of the distilled water in a test tube. Then you're going to add 5 drops of phenolphthalein, and you're going to make sure that it's mixed with the water. And you do that by tapping the side of the test tube with your fingertip very gently. And you're going to record any observations. So what do you see? When you observe, you are using your senses. So anything that you observe about it, whether it's sight or something that you smell, don't taste it. I never recommend that you taste things, but make sure that you write down anything that you notice. Okay, and then the next thing you're going to do is you're going to put a small amount of calcium oxide into the test tube, and again you're going to observe and record any changes. So remember the study that we did, the video lecture that you watched on indicators of chemical reaction. So you're going to be looking for some sign that a chemical reaction or change has taken place. Then at the end of this lab, at the end of this lab, you are going to be doing some work with the chemical formula for the reaction formulas and doing that. So the procedure is very simple and short. All right, the next chemical reaction type that we are going to talk about are decomposition reactions. And in decomposition, you have a separation of a chemical compound into elements or simpler compounds. So the example is like this. All right, so you have a chemical compound AB. AB. Now this little line in between denotes that there is a bond there. So that is a compound, okay? And we're not talking right now whether it's ionic or molecular, it's just a compound. So AB is a substance or a chemical compound itself. In a decomposition reaction, that reactant, where there's only one reactant, AB, it is going to yield, decompose to yield A and B. So now they're not together, they're separated. So there's a breakdown, if you will, of the compound into its individual components. So the example that I'm using here is H2O2, and this is the chemical formula for hydrogen peroxide. You often use it when you have a cut or something and you want to disinfect it, and you put it on it and it bubbles. If you've ever used that, or your mom's ever used that, you know what I'm talking about. Okay, so hydrogen peroxide will very easily decompose into water and oxygen gas. Okay, so when the bubbles are forming, that's what's happening. Okay, it's breaking down into water and oxygen gas. And you remember one of the indicators that a chemical reaction is taking place is gas formation or bubbling. So this is definitely a chemical reaction. In your lab, you're going to be using a test tube again. You're going to be using a test tube holder. That's what this is, a test tube holder. And you will be given some sodium hydrogen carbonate. That is the chemical compound. You will have a Bunsen burner, and remember this is an open flame, so you will definitely need my and Mr. Hunt's supervision to help you with this. Don't be playing with the flame. It is not something for you to amuse yourself with. This is for our lab, so please be careful. And of course, anytime you're working with open flame or heat, it's a good idea to wear the lab gloves, the heat lab gloves. Okay, in this procedure, you're going to put some of the sodium hydrogen carbonate into the test tube, and then you're going to use the test tube holder to grip the test tube, and you're going to put the bottom of the test tube actually into the flame of the Bunsen burner. Now this is very important. That's why it's in red, people. This is very, very important safety measure here. You're going to make sure that the mouth of the test tube is pointed away from people, from yourself, from your lab partner, from me, and from Mr. Hunt. We don't want anybody to get injured. Okay, and I don't think that anything would happen, but it's just good safety in the lab. Okay, so after you do that, and here's a picture showing how that works. They're not using a lab glove, but I recommend that you all do if you're doing this. Okay, and you're going to be looking at the mouth. This is the mouth of the test tube up here, the opening. That's what we call that. And you're going to be watching what happens there, and you're going to record your observations. So again, a very simple procedure. Excuse me. This is a short link to the Google presentation, but you will also have access to it on the Moodle page. So please take the time to review the procedure, review the safety precautions before you come to the lab next week. Thank you.